So 11, before we get started with the lesson for today, I'd like to do a quick review of what you have covered yesterday on volumes of prisms and cylinders. So remember, the volume of a prism is the cross-sectional area times the height. So if you have a rectangular prism, okay, the volume is area times the height, where the area is the area of the cross-section. And the height is the height of your prism, or the depth of your prism. The first question that we'll be looking at is question 11 on exercise 6G. The question is, find the volume of an equilateral triangular prism with side length 3 centimeters and a depth of 10 centimeters. I'm going to round this to 3 decimal places. Okay, so the first thing you need to do is you want to draw in your diagram. So this triangle base has side lengths of 3 centimeters all around, because it's an equilateral triangle, and it has a depth of 10 centimeters. We can label that in as well. Let's write down the formula for the volume of a prism. V is equal to A times H, where A is the area of the cross-section, which is this triangle here. So I'm going to actually draw this again here. Now we know the area formula for a triangle is half times base times height, where B is the base of the triangle and H is the perpendicular height. So we want to know this height. Now we're given the B, so we can write that down, half times 3, which is the base here, but we are not given the height, so we need to find that. In most cases, you'll be looking to use the Pythagoras theorem to find your perpendicular height. So you've got to look out for your right angle triangle. In our example here, we have the sides being 3 centimeters all around. And if you have a look here, we have a right angle triangle with our perpendicular height as one of its sides. So this length at the bottom of this triangle is half of 3, okay, which is 1.5 centimeters. Okay, and the hypotenuse is 3. We have 2 known sides out of the 3, so we can find the unknown height using the Pythagoras theorem. Okay, so A squared plus B squared is C squared, where C is the hypotenuse. So we can replace that with 3. A and B are the length of our shorter sides, so 1.5 squared and H squared. Okay, then we just solve for H. And so H squared equals to 3 squared minus 1.5 squared. H is the square root of all of that. Okay, which gives us a square root of 6.75. Now this is an irrational number, so it's going to give us a very long decimal number. So we want to just keep that form, that number form in our working out. So let's substitute that back into the area formula. Okay, so B times the square root of 6.75. Okay, that's 1.5 times 6.7, it's the square root of 6.75. Okay, and that's the number that you'll be substituting into your volume formula. So the A is 1.5 times the square root of 6.75 times the height of the prism, which is 10. So you multiply that by 10, and that should give you the number 38.9711. And it keeps on going. So we want to round that off. 38.971 cubic centimeters. We rounded this off to 3 decimal places. Okay, so that's our answer. Let's have a look at the next example. In this example, we want to find the volume of this solid. We can see this solid is a prism because no matter where we cut this solid across the length of the solid, we can see that we'll get this shape at the front, which is the cross-section area. And so let's write down the formula for the volume of a prism, which is A times H. where A in this case is the area of a semicircle, which is half of pi r squared. Now we've got to be careful not to use the 3 down there, because 3 here is the diameter of the semicircle. Okay, we need to halve it to find the radius. So the radius is 1.5. Okay, so the area is half times pi times 1.5 squared. That gives me 1.125 pi on the calculator, and then I substitute that into my volume formula for A, 1.125 pi times the height, which is 20. That'll give us the volume of that solid, 70.685. Okay, and that's approximately 70.7 cubic meters to 1 decimal place.